Hello everyone, I hope you are all doing well. In this video, we are going to learn about the OSPF protocol, and we will be discussing that how can we construct a OSPF protocol in packet tracer, and what are the basic usages of the OSPF routing protocol. So OSPF stands for Open Shortest Path First Routing Protocol. So basically, it is a protocol designed for the routing purpose. As we know that we need routers for the successful communication between the networks. So if we have different networks, then we need to configure different routers so that these different networks can communicate with each other. So in past there have been some routing protocols, but due to some limitations and due to some uh, uh, weak points, those routing protocols were not able to solve some problems. But OSPF has emerged as one of the best routing protocols, and it can solve the problem of limited number of hops which we have seen in the RIP protocol, known as routing information protocol. So OSPF is basically intra-domain routing protocol based on link state routing protocol, and it uses SPF, or shortest path first, or you can say that it uses Dijkstra algorithm. And in OSPF we don't have any limit for the number of hops or number of nodes, you can say. And it's a classless routing protocol, plus for load balancing it share the equal cost for all the nodes, and it also provides the authentication for the routing messages. So this is the brief introduction of the OSPF routing protocol. Now I'm going to construct an OSPF routing protocol network in packet tracer, and I will guide you how you can set up OSPF network in packet tracer step by step. So first of all, we need three routers here. I'm putting them in our working space here in packet tracer. Then we need to have two different PCs here, so we can send a message from PC0 to PC1. In next step, we need to connect these devices with each other. So we need to connect these devices. So for connection between the routers, we need a port which is multi-protocol synchronous serial port, and for this we need to power off this router and put the port in its slot here, and turn the router on. Same step will be performed for all the routers here. Just power off this router, put the port in the its slot, and turn it back, turn it on. Next router is, this is already set up, this one is remaining, so we need to put this port in this slot. So all the ports have been allocated. Now we need to connect the routers using serial ports. Okay, so we have successfully configured the uh, different devices here, 3 routers and 2 PCs here, and we have connected them successfully. And now we are going to our next step is to assign the IP addresses to all these links and devices. So first of all, for better understanding, I am writing down the addresses, network addresses. So for this I am using 60.40.30.0, and for this link I'm using 172.168.1.0. For this link I'm using 12.0.0.0. This link will be 10.0.0.0, and this link is 11.0.0.0. So now we need to assign the IP addresses to the devices. For this PC we are going to assign the IP address 60.40.30.2. Just copy this and put the gateway as 30.1 and remove this DNS. Similarly, go to PC1 and uh, assign the IP address as 172.168.1.2. Just copy this and assign the gateway as 1.1. Okay, we have successfully assigned the IP addresses to the PCs. Now we need to turn these red ports into green ports. For that we need to go to the settings of the router, click on CLI, and first of all we need to configure this router 0 port which is going towards the PC0. So just press no, enable config t, and now we need to provide the interface is gigabit 0/0/0, and IP address for this is 60.40.30.1, and subnet mask is 255 as it is class A, so its subnet mask will be 255.0.0.0. And now we need to um, write down no shutdown, and you can see this port is now turned to green, which means that it is now working. Now we need to go to this link which is 12.0.0, which is going from router 0 to router 1, and its serial port number is serial 0/2/1. So go to command line again, exit from this port, interface serial 0/2/1, right, and its IP address is 12.0.0.1, and its subnet mask will be 255.0.0.0. Okay, no shutdown. Now we need to configure this third link from router 0, which is going from router 0 to router 2, and its network link is 10.0.0.0. so we need to check the port number, which is serial 0/2/0. So go to command line again, exit from the previous port and exit interface serial 0/2/0. IP address will be 10.0.0.10.0.0.1, and Subnet mask will be 255.0.0, right? No shutdown. So we have successfully configured the three links going from router 0, and now we need to exit and save these settings, and just type copy run st. We can do this from this port here, this interface here. Just click on save, and this will save the information which we have just performed on this router. Now we need to go to router 2, and we have to configure its two links, which is router 2 to router 0 and router 2 to router 1. So we need to check the port number here, which is uh, serial 0/2/1, which is going from router 2 to router 0. So enable config t, and interface is serial 0/2/1, and IP address is 10.0.0.2, and subnet mask is 255.0.0.0. No shutdown. As you can see that this port is now turned to green. Now we need to exit from this port and go to the next port, which is serial 0/2/0. So interface serial 0/2/0. IP address for this link is 11.0.0.1, and subnet mask is 255.0.0.0. No shutdown, and this link will also be configured. Now just go to configure and save the settings we have just provided to this router. Now we need to go this last router here, which is router 1, and we need to configure all these three links going from this router. So first of all, go to command line and no enable config t, and now we need to configure the interface serial 0/2/0, and IP address is 12.0.0.2, and its subnet mask is 255.0.0.0. No shutdown, and it will be also turned to green now. And exit from this port. Our next link is serial 0/2/1. This is the link from router 1 to router 2, and its IP address will be 11.0.0.2, and its subnet mask will be 255.0.0. No shutdown, and this will also be turned into green. Now we have only one link which is still not working, and this link is from router 1 to router PC1. So just exit from this port and assign interface gigabit 0/0/0, and IP address is 172.168.1.1, and subnet mask will be 255.255.0.0, as this is class B network. So no shutdown, and you can see that this link is also enabled now. Just go to configure and save these settings. Now we have successfully configured the devices, and we have given them the right network and IP addresses. but still the communication will not be able to we will not be able to communicate between PC 0 to PC 1 because we have not configured any routing protocol on these routers. So as we have studied in the start that we are going to deploy OSPF protocol here, so we need to go to each router and we need to assign a network an OSPF ID, and we have to provide all the network to that router which are connected to the other routers. So first of all, go to configure command line and config t. So we are in configuration mode. Now we need to provide a command here which is router OSPF, and then we have to provide a number here. A number will be acting as a OSPF ID, and you can assign any number here, 1 2 3 or any number here. I am assigning 1. This is the part of the syntax, and when you press enter, then you can see that you have now entered into the configuration of the router. So in this configuration, or in this command, we have to provide all the networks which are going from this router. So first of all, write network, and then we have to provide the network addresses. So network address for PC 0 to router 0 is 60.0.0.0, and next part is to provide the complement of the subnet mask. Complement mean we have to reverse the subnet mask here. So in this case, the default subnet mask will be 255.0.0.0. So we have to take the complement of the subnet mask. It means we have to reverse the network address into host address. So 255.0.0.0 will be converted into 0.0.0 sorry 0.255.255.255, right? Sorry, we have to provide an area as well. So just write network 60.0.0.0, and the complement of its subnet mask will be 0.255.255.255, plus we have also we also need to provide a area here. Area is basically the group of devices which are in the same network. So we are using area 0, which is also known as backbone area. So just press enter. So we have successfully entered this network into an OSPF area. So our next network is from router 0 to router 2, which is 10.0.0.0. So network 10.0.0.0, and its complement of its subnet mask will be 0.255.255.255, and its area will be also 0. Press enter, and the last link is from router 0 to router 1, which is 12.0.0.0. So write network 12.0.0.0, and its complement of his subnet mask will be 0.255.255.255, and its area is also 0. Press enter, and we have successfully configured all these three links from router 0. Just press exit and go to config and save these settings. Close this window. Now go to router 2. From router 2 we need to configure only two links here. So enable config t and write same command router OSPF 1 network um, from router 2 to router 1. From router 2 to router 0 we have link which is 10.0.0.0. So network 10.0.0.0 and its complement of its subnet mask will be 0.255.255 and its area is also 0. Network 11.0.0.0 complement of its subnet mask, we need to write it again, network 11.0.0.0 0.255.255.255 and its area is 0. So just press exit. We have successfully configured its two links. Now go to config and save these settings. Close this window and now we have only left with router 1. So router 1 have three network links. So first of all, config t enable config t and write router OSPF 1 network is 172.168.0.0 and its uh, complement of its default gateway is 0.0.255.255 and its area will be 0. Similarly, our next link from router 1 to router 0 is network 12.0.0.0 and complement we have something okay, so 12.0.0.0 and its complement of its subnet mask will be 0.255.255.255 and its area will be 0. And last one is network 11.0.0.0 and its uh, complement of its subnet mask will be 0.255.255.255 and its area will be 0. We have successfully configured all the links from router 1 as well. Just press exit and save these settings. So till now we have configured all the network addresses and we have also enabled these routers using OSPF protocol. So now we need to send a message again from PC0 to PC1. The first message will be considered as failed because it will be used as the consumption for the routing table, for the updation of the routing table. Just delete this message and send the message again and we can see that the message is now successfully sent and all the devices now communicate with each other, right? For further validation of the OSPF, we need to check the real-time simulation of the packets. So just just send the message from PC0 to PC1 and plug and play this uh, packet tracer here, which is capturing the packets from one device to another device, and you can see the you can see that uh, algorithm is deciding the shortest path on its own. You can also check the further details by using these filters here. These are the filters, or you can say that you can see the details of the packets from uh, for the transmission of the network, and we can see this OSPF option here. So you can use this option as well. So this is the today's lecture. I hope you have understand this topic, and you will be able to configure and construct an OSPF protocol in packet tracer now.